When we look at this vocabulary word that we're focusing on today, we know what an angle is. We know what addition is. What does postulate mean? Well, it means that this statement, this conclusion will be true for all the situations that look even remotely close to that. Okay, so we know what angles are, we know how to add things, and then a postulate is a rule that can be applied to many different geometric situations. So looking here at our picture, if D is in the interior of ABC, which it is, here's D, here's ABC, it's in the interior, then we create these two different angles. The first one is this, ABD plus DBC. So when you add together the two small ones, it will equal the whole. Angle ABC. Angle addition postulate. So as I walk around, if you're forgetting to add the parts and equal the whole, I will refer you back to this postulate. Okay, we've got quite a bit of examples, and they have a progression. They start out with just numbers, they progress to expressions, then they go on to where they're using words to describe an expression, and then they'll give you the scariest pictures in the history of man. So that's kind of where we're headed. And we're not going to do all these examples. It would take the entire class. So let's start with this first one. Use diagram below to answer questions 1 and 2. Carly, will you read number 1 for us? And again, this little m, you read the measure of. That's how you say it. Yes?
Why do we need the m to say that it's the measuring? Isn't the little angle symbol what that's for?
I think it's because they're telling you the degree of the measure instead of just mentioning an angle. It has something to do with when it matches up with the degrees. Because in a little while we'll be talking about the arc, like it's a different distance.
So it's like f of x. It makes sense, but not really.
It does make a little more sense because, like I said, we're going to be moving on to finding, well, actually, I don't know if you do it this year, the measurement that's not the angle. Like we still will call it ABD. We'll still have angle ABD, but it'll be an arc and it'll be a slightly different connotation. So this specifically means that we're measuring the angle in degrees. So yeah, they are pretty particular about having it, but I can see what you mean that you feel like it's not necessary.
You can like get rid of it, like substitute f of x for y.
Kind of like that. I don't know. Okay, the first thing I would like you to do, and as I told you on your homework, you will get credit for doing this step. You will get credit marked off if you don't do this step. You need to draw, that's the wrong word. You need to put the information from the directions in your diagram. In geometry, if you get in the habit of doing this, it will make your life easier when we get to proofs. If you're not in the habit, proofs are a mess. So for example, on number 1, like Carly read, the measure of ABD. We'll find ABD. Put your finger inside that angle. Where is it in this picture? Okay, and then label it 48 degrees. And DBC, find that, it's this next one, and label that one 78 degrees. And they want us to find the measure of angle ABC, and we use the angle addition. Hey, birthday? Whose is it? Happy birthday to you, happy birthday to you, happy birthday, dear Bryce. Happy birthday to you. I think he loved that so much today. Oh, I didn't recognize you after your haircut.
Yeah.
You were a good sport.
We didn't. It's getting better. But it's really nice to do, actually.
I know, it's so fast. It's like shower and all those things. Thank you. He's here today.
Yes.
It's a total ACL tear, and Tuesdays is operation. Yes. He's in good hands? Okay, thank you. All right. I think you all can figure out that we are doing what to find the whole? We're adding them together. So I don't really care if you write that part down. This is important to me. If you want to add them in your head or type them in your calculator, that is fine. But we are doing the angle addition postulate, so 48 plus 78 is going to give us the whole. If you need to get a calculator, go grab one. It will not hurt my feelings that you get up and go get it. You're not the only one. Shaylee, what did you get when you added these? Okay, one thing I hate about this particular problem is they're giving us completely different numbers for this next equation. So you're not going to be able to do this, but I will. Angel, will you read number 2 to us?
Measurement 60 74.
Okay. It's really hard when they give you the whole angle because you feel like you just want to write it on top of everything. But wouldn't that be a disaster? So the way that I have chosen to do it is I make kind of an arc. This reminds me, this number is the whole thing. Like they're giving me this right now. So on this one, they said it was 119. And I don't know ABD. This is my unknown. Maddie, how can I find that unknown? The x. Yes. And once again, this is what I'm looking for. If you want to do that subtraction in your head, not even a big deal. But it comes from part plus a part equals a whole. And then, like Maddie said, we would be subtracting to find that answer. Some people like to write it out. They're all adults. There are 0 students who like to write it out. So Maddie, what did you get on that one? So I hate that they use the same picture for 2 examples that are way different numbers, but it's the only one that they do that with, so it just is what it is. So the measure of angle ABD we found is 45 degrees.
You have to use an X.
Nope. In fact, I would probably put the measure of angle ABD equals, oh, I didn't leave myself enough room. Like that's the most accurate way to do it. Okay, gone into my other box. We are not doing every single example. I'm skipping around a little bit. If you are going way faster than I am on the board, you're welcome to come back and fill in some of these that I'm skipping. There's nothing wrong with them. There's just a ton of examples that we don't need. So this one, they already wrote this stuff in. We would add it up and set it equal to 141. We're skipping that one. Okay, number 4. Elizabeth, will you read number 4 for us? So you say if the measure, that's how you read it. If the measure these are the specific measures that they want you to find. Please label your picture. Did everybody already do it? Label the parts of your picture. What's the part? What's the other part? What's the whole? How do you do it? You can solve now if you want. If you've already labeled it, set up the angle addition postulate. This one's more difficult than the 2 we did up above because they're expressions instead of just numbers. All right, so I'm going to catch up with you. DEF is the big one, and it's 7x plus 4. DEG is this one here. It's going to be hard for me to fit it. 5x plus 1. And GEF is the smaller one. It's 23 degrees. Hayden, how do I set up an equation to find x using the angle addition postulate? I'll get you started. So what do I put over here?
Oh, which you taught it.
Yes. Yes. So like I said, this is a little different from the one up above because it's not just numbers. They gave us a whole hot mess. And now we get to take a minute and solve for x. Some students were struggling with this earlier, so I'm just going to review how we do it. If you've got a bunch of stuff on one side, you want to condense it down to just two terms, something with an x and the something without the x. So I'm noticing that these two don't have x's, so I'm going to put them together. It's a lot easier to solve if you have, I do not know what's going on with my board right now. This is a lot easier to solve than three terms on that side. Cooper, what would I do next? Yes, there are 4 correct steps right here. So if you thought of something different than Cooper, it's probably right. I would have done that too, because then my x's will remain positive. Okay, so finish solving, find out what x is. I'll give you just a couple more seconds. Yep. It absolutely does matter. The postulate says that the little angle plus the little angle will equal the whole. So this one that's the whole thing has to be by itself over here, and the little ones have to be added together. So if you accidentally added the big one, it would end up something funny. All right, Cooper, what did you end up getting for x? 10. Seth, once I have x equals 10, how do I find the measure of DEG? Not this expression, but the actual degrees. Yes, so I'm coming back here. I'm seeing it's 5x plus 1, but I know that x is 10 because Cooper told me that. So it's 51 degrees. Same thing, if it says to find DEF, which is the big one, well, you can add 51 and 23. You could add 51 and 23, or you could use this expression. Instead of 7x, we know x is 10. Yeah. Well, Cooper finished solving his. I did not. Did you finish solving yours? Oh, okay. That's where the 10 came from. Okay, as you look at this, is there any part that you're not sure how I decided what to do? And I am giving points for drawing the information in your picture. It's just going to be part of it. Okay, let's turn to the other side of this page. We're going to go to number 6. Corbin, will you read number 6 to us? The measure. When it's an M, you read it the measure of. So a minute ago, Julian was asking me about this M, and it is necessary. Do you see how they did not put it here? Because they weren't telling us the measure. They were just giving us information about it. So it does mean that the information following will go inside it, and this one wasn't giving us the degrees. We had to figure it out ourselves. What does a straight angle mean? So let's label that. Again, I just like to use this big arch. I don't know that that's universal, but it makes sense to me to remember that that's the whole thing and not one of the parts. I can't think where else I would write it. If you come up with a better way to organize it, go ahead and do it. Okay, DEG, it looks like is here, and it's 23x minus 3. And GEF is 12x plus 8. Now you're set. How would I set this up using the angle addition postulate so that I can find all of these things? Some kids were setting these equal to each other. I don't know why. A lot of kids put equal right here, and they completely ignored the 180. So I'm not sure what these different pictures, why our brains think that it might be a bisector, but it doesn't mention that. It just says it's 180 degrees. Okay, well, how much time do we have? We're still doing okay.
Why is it different now that it's on the end? Because before you didn't have it on the end, like the number. It's like 180 plus, or like in the problems before you did like the division and then 23. So why is it different now?
So I put the 23 here. I'm not sure if I understand your question, but I'll explain to you how we do. So these could be switched. I could have the 23 first, but the little angles that are created by this ray, they're the ones that are being added. And then whatever, does that make sense? So I don't know if there's a pattern with where the number is versus the expressions. The pattern is little angle plus little angle will equal whatever they gave you for the whole one. Okay, did everyone? Okay. I know, that's why there's so many examples, I think, because you're going to see it so many different ways. All right, I'm going to hurry and solve mine. You hurry and solve yours. I'm combining my like terms. I'm combining these like terms. I'm sliding this over because it's like in the way. I'm skipping steps, so if you're trying to write mine down as fabulous notes, I don't know that they're that fabulous today. See, once you have your x, see if you can plug that in and find those 3 missing angles. Actually, one of them we already have, right? D, E, F, we already know. Ooh, that is very bright. Okay, I had a student ask me a question earlier, and I was glad they were brave enough to ask it. I just want to make sure you guys understand something. So she said to me, on this very first step, why didn't you subtract 12x like this? Shaylee, why don't I subtract 12x like this? Yes, now I didn't walk around to see if anybody was doing that. If your brain wanted to do this, right, instead of combining them together as 35x, when I see that equal sign, I think of those when you go to the lawyer offices, they've got those chains and the 2 plates, and it represents justice, and they are balanced. Do you know what I'm looking at, or what I'm seeing in my mind? So this 180 is here, and it's balanced. It's equal to all of this. If I subtract 12x twice from this side, it's not balanced. That will be much lighter. Correct? It will take 24 x's off of one side. We are not balanced anymore. So another way to think about it, we don't do the same, we do it to the different sides, but here all we're doing is we're taking all this messy stuff on the plate and we're cleaning it up. Then you can subtract things from both sides. Like I subtracted 5 from both sides. I divided both sides by 35. But this idea, will throw some people off still. That combining like terms, they just really want to do inverse operations to the same side. Okay, Peyton, once you had x equals 5, how did you find DEG? Yes. Elizabeth, where did the 5 come from? Yes, we found it by solving the x. And then there's a couple ways to find your other one. You could do 180 minus whatever you got here, right? Or you could plug the 5 in to the 12x minus 8. So 30, oh wait, wrong equation. 112 and 68, is that what we got? Okay. The next few we're not going to solve. We're just going to draw the pictures and set them up. I think that we're good with combining like terms. I hope so. Number 8 is a little bit different. Were you trying to write that down still, Matthew? You got it? Okay. Did I already have you read, Angel? Oh. I don't know. I lost track. Oh. I always want to call him their own name. Cody, will you read number 8? Okay, that is not very fun that they made it in disguise. I'm going to label this, though. I can do that pretty quick. BCD is the whole thing, and it's a 162. So kind of like Kennedy was asking me a minute ago, the 162 I know is going to go over here because it's the entire thing already added together. What in the world do I do with this other part? So the first thing we're going to do, they're giving me angle ECD in terms of this guy. So if part of ECD is a different angle, I need to give it some type of a name. You can call it X, Y, Z, or whatever you want. I'm going to call it angle Y. Once I give BCE, once I call it angle Y, this is going to make more sense. So 6 less than 5 times BCE. That's how I'll write it. The 6 less than is funny. You do work backwards. When it says less than, you put the 6 and you move to the left. So this is 5y minus 6. And this is y. Make sure you have that written down. There's one like that on the homework. And we're not going to solve it. I think we've practiced solving it. It's writing the equations that we were practicing. Any questions on that one? Where they give you these clues and you got to come up with the, oh, there's only one. Okay, the last one, and all we're going to do is draw it on the picture, is number 10, because it is a lot. And you'll want to keep your notes handy that talks about a perpendicular bisector. So remember, perpendicular things meet at 90 degrees. A bisector divides things in 2 equal angles. Who haven't I had help? Ethan. I haven't had you help. Ethan's going to read number 10 for us. Okay, stop there for a minute. Will you guys draw something in your picture that shows that angle CBE has been bisected? I hate the little arches. I always do. So CBE is this guy. He's being bisected. That's the markings that I do. So I know those 2 angles are equal. And it's going to be important when you start solving stuff. Yeah. Yeah, so you see, like, oh. Oh, it just they are bisecting. A segment bisector makes 2 equal segments. An angle bisector creates 2 equal angles. Okay, Ethan, resume. We drew that in. Pause. That actually means perpendicular. Okay, what does perpendicular mean? They create 90-degree angles. So let's go find BC. BC is here again. BA is here. So what kind of angle is that going to be? A right angle. Okay, I drew that. All right, Ethan, resume. Done. Yeah. Oh, he's going to finish. Okay. You're good. Yes, Peyton? Yes. Do we use segment addition postulate for this problem? Do we know the whole? No. So on this one, we are using this idea, like Bronson was saying, I didn't realize an angle bisector made two equal angles. So 3x plus 25, I don't know why I'm writing it up here, equals 7x minus 19 for this problem below. I don't know why I'm writing it in the wrong spot. It has nothing to do with this. So for this particular problem, if you're like, Mrs. Mitchell, they didn't tell me what they added up to be, you can use this information. And we're trying to find A, B, F. This is special. We're trying to find this one. How is that even possible? D, B, E. I am not sure. Oh, A, B, D. Find A, B, D. Oh, we're trying to find this one. Oh, I see. Okay, I'm going to hurry and solve this one because we got to start working on your homework. 3x. Okay, so on one like this, just you got to be like a super sleuth with all the information they gave us. And 11? I went very fast. Did anybody else get something besides 11? Did you set them equal? And you moved? Oh, it's negative 44. Uh-huh. So you would have ended up with that, which is... Okay, on your homework, I want you to start out and do the evens, 2, 4, 6, 8, 10. If you are so speedy fast that you get those done with time left, please go do the odds, but I want you to do the evens starting out. So 2, 4, 6, 8, 10. So that's, oh, let me stop my recording.